Hi everybody. So this next section 4.3, we're going to get into stuff that might be a little bit more difficult here. Again, this is probably stuff that you've done before, but dividing polynomials I think is a little bit trickier than adding and subtracting or multiplying polynomials. So what we'll first of all is we'll talk about dividing a polynomial by a monomial. So this should say dividing polynomials, I guess. By a monomial, so that'll be basically dividing something with several terms by something with one term, and then we'll look at polynomial long division, which is similar to what you did when you divided numbers using long division, and then we'll look at kind of a shortcut for dividing polynomials, which is called synthetic division, and then we'll look at dividing polynomial functions, which would be very similar to what we do when we divide just regular polynomials. And then we'll use the remainder and factor theorems. Let's talk about how to divide numbers here first of all. So you might remember, for example, if you wanted to take, say, 23 and divide it into 460. Remember, this thing up here is called the quotient. The thing you're dividing by is called the divisor. And the thing you're dividing into is called the dividend, right? So in this case, 460 would be the dividend, 23 would be the divisor, and 20 would be the quotient. And one thing to remind you about is if you want to check your answer upon division, right, you can take the dividend, which in this case would be 460, and that should equal the answer, which again is sometimes called the quotient, times the thing you're dividing by, plus the remainder if there is one. Now in this particular case, there is no remainder, so that means that 460 should equal 20 times 23. Maybe just to remind you how this works with the particular example here, right? So what you want to basically do is, if you divide, say, 247 by 23, what you want to do is ask yourself, first of all, what would you multiply 23 by to get as close to 24 as you can without going over, right? So that would be a 1. So take 1 times 23, which is 23, and then just subtract. That'll give you a 1. Then bring down the 7, right? And so 23 won't go into 17, so you would just take 0, multiply that by 23, which would give you 0, right, and you get a remainder of 17 there, right? So, and then you can keep going like that if you want to write it as a decimal, but we don't want to do that. But in this case, again, if you wanted to check your answer, right, 247, the dividend should equal the divisor times the quotient plus the remainder, which it does, right? 247 is equal to 230 plus 17, right? So that's how you do long division. So remember, you just sort of take this thing up here times that and then subtract, and then just keep bringing down numbers down. And again, you could continue to write this as a decimal if you wanted to. And then just to remind you, you can write the answer in several different ways, right? You could write the answer as the quotient plus the remainder over the divisor if you don't want to write it as a decimal, right? This should be equivalent to the decimal, right? If you were just to take 17 divided by 23, it would give you the decimal number there. Some books will also just let you write the quotient with remainder equal to 17. And we'll see that it's usually preferable to write the answer this way. But I might let you write the answer this way on written exams. Again, on my math lab, you should typically write the answer in the way they ask for it. But So just to reiterate this again, right, so the same thing will happen with polynomials that will happen with numbers. So let's let p of x be some polynomial, right, and let's say you're taking some polynomial p of x divided by some other polynomial d of x, right, so this would be the divisor and the dividend. Then that will equal the divisor times the quotient plus the remainder, just like when you're doing regular division. So the question is, well, how do you divide polynomials? Well, we're going to look at dividing a polynomial by a monomial first. So let's say, for example, you take 10t to the fourth minus 35t cubed plus 5t squared over 5t squared. You can do something similar to the long division we did before, but if you only have one term in the bottom, if you think about it, right, you can actually write each term on the top over the bottom separately. And then you could just reduce each term, right? So 5 goes into 10 twice, t to the fourth divided by t squared will give you t squared. So remember here you would subtract the exponents. So, right, so 4 minus 2 is 2. 5 goes into 35 7 times. 3 minus 2 gives you t to the first. And then anything divided by itself is just 1. So that should be the answer. And then again, if you do want to check your answer, I'm not going to take points off if you don't check these, but I would strongly encourage you to check them, right? I mean, if you're not sure if that's right, take the quotient, right, the 2t squared minus 7t plus 1, and multiply that times the divisor plus whatever the remainder is. In this case, there is no remainder. And just go ahead and multiply that back through, and you should get the numerator, right? You should get the dividend, which I think you will get, right? You'll get 10t to the fourth minus 35t cubed plus 5t squared. So just to do a couple more examples, right? Like, so for example, for this one, you could just write this as x squared over x plus x over x, and that would be x plus 1, right? And that would be your answer. Right? For something like this, you could take 3x cubed over 3x minus 9x squared over 3x plus 6x over 3x. And you could just write that as x squared minus 3x plus 2. And then that would be your answer for that one. And again, you could certainly check those if you wanted to. But that's all you have to do for those. And you can do these using long division. We'll maybe talk about that in just a minute. But if the thing on the bottom is a monomial, if it only has one term, you can always write a fraction like that. So let's look at what happens if you do have something other than a monomial on the bottom. Let's say you've got a polynomial here like c plus 1. So this is not a monomial. It has two separate terms. How would you do long division in that case? Well, you do something very similar to what we did back here when we did this problem. The process is pretty much identical, but there is a little bit of a difference here. But basically what you do is you would want to write it in this form, right? So this is your divisor, this is your dividend, and I guess the way I do this is I start out by asking myself, what would I multiply this by to get the first thing here, right? So I'd multiply c by c to get c squared. And the only thing is whatever you write up here, you have to multiply it times both of these things here, right? So, so you'll get c squared plus c, and then you would subtract, just like we did in this example, right? We took 1 times 23 and got 23, and then just subtracted. So if you do that, the c squareds will cancel, right? Because you've got c squared minus c squared, and then you'll have 3c minus c, which will give you 2c. And then just like we brought down the 7 here, right, we got 1 and brought down the 7, we'll do sort of a similar thing here, just bring down the 2, right? Bring down the negative 2, and then just go ahead and do the procedure again, right? In this case, you'll get negative 2 here. And then what you would want to do then is just go ahead and put plus 2 up here, right? Because c times 2 is equal to 2c. So you kind of start over again and ask yourself, what would you multiply this by to get, or excuse me, what would you multiply this by to get 2c? Well, you'd have to multiply c by 2. So you'd put a 2 up here, again, take 2 times c, which give you 2c plus 2, and then just subtract again. So those cancel. You get negative 2 minus a negative 2, which gives you negative 4. And then you can stop once the degree of this polynomial is less than the degree of this polynomial. So, you know, there's no c here. You could think of this, I guess, as c to the 0. This is c to the first, so you can stop. And then this would be your remainder. And again, you can write the answer in a couple different ways. Like I said, you could say the answer, you know, here's your quotient. You could say the answer is c plus 2 with remainder equal to negative 4. Or I think what's better is writing the original fraction as your quotient plus your remainder over the thing you're dividing by, right? Divided by the divisor. And again, you can always check that, right, by taking the, if you're not sure if that's right, take the quotient times the divisor, right, multiply those two things together, and then add the remainder, and you should get the dividend, right, the thing inside the division symbol, which you do get. Here's another example. So let's say I want to divide y squared minus 5y plus 6 divided by this. Again, you would write it this way. Going to ask yourself, what would you multiply y by to get y squared? Well, you'd multiply by y. So take y times y minus 2. That'll give you y squared minus 2y. And then remember, you have to subtract each one of these. So I'll subtract here, and then if I subtract a negative, that'll be the same thing as adding. So then y squared and the minus y squared will cancel. Then I'll get minus 5y plus 2y, which will give you minus 3y. Bring down the 6, and then again ask yourself, what would you multiply y by to get negative 3y? Well, you'd multiply it by negative 3, so take negative 3 times each one of these. So that'll give you negative 3y plus 6. And then again, you need to subtract each one of these, so that'll change the sign there to a minus, plus, and there to a minus. Now, if you add in this case, you get a 0, so there is no remainder, right? So that means that in this case, if you take y minus 3 times y minus 2 plus 0, because there's no remainder, you should get what you got there. Let's maybe do another example here. I'll kind of work this one out a little bit. But let's say you want to divide this, right? Again, you could write it like this or this. Again, if you want to do the division here, you'd want to write it this way. So again, what would I multiply x by to get x squared? Well, I'd multiply by x. And it really doesn't matter where you put this up here, but I guess I like to line things up. Like if this is the x to the first column, I like to put that up there. But take x times x, which is x squared. Takes 3 times x, which is 3x. And then just go ahead and subtract those, which give you x, and then bring down the 8. So then just go ahead and multiply that by 1. So you'll get 1 times x, which is x, 1 times 3, which is 3. Again, you'd want to subtract each one of those. So you'll get 8 minus 3, which is 5, and then that's your answer. So the answer is x plus 1 with remainder equal to 5. Or a better way to write it, again, would be the quotient plus the remainder over the thing you're dividing by, or the divisor, right? Whichever way you want to write it on the written exam is fine with me, but in my math lab, if you're using that, right, try to make sure that you put it in the form that they want. And again, you could certainly check this by taking x plus 1 times x plus 3, adding 5, and it should equal x squared plus 4x plus 8. I won't bother checking this one, but let's maybe do another example. Now, one thing you do have to watch out for when you're doing division like this is you might have missing powers, right? So if you think about what this really means you're taking x cubed plus 0x squared plus 3x minus 6 divided by x minus 1, right? So it'd be kind of like if you had, 1036, right? You wouldn't just write it as 136, because remember this number tells you how many x's or powers of 10 you have, right? So the only thing is, whenever you're doing long division like this, if you put in, if you have a missing power of x, if the power goes from, like, say, degree 3 to degree 1, you have to put that in, and you also have to put it in the thing you're dividing by, the divisor. But in this case, the power does go from 1 to x to the 0, so you don't need to do that. So in this case, when you do the division here, you'd want to set this up as x minus 1 divided into x cubed plus 0x squared. Sorry, I almost forgot to put my 0 in there. Minus 6. And then just do the regular long division once you've already you've already done it before, right? So again, what would you multiply x by to get x cubed? That would be x squared. Take x squared times each one of those will give you x cubed minus x squared. Then you have to change the sign because you got to subtract, and then bring down the x squared here. And then here I should mention that you might wonder, well, how many terms do you bring down here? Well, you bring down as many terms as you have in this expression. So you have 1, 2 terms here. So just bring down the 3x. You don't need to bring down the negative 6. And then kind of start over again, right? So what would you multiply x by to get x squared? You'd multiply by x. So take x times x, which is x squared. Then you take x times 1, which is minus x. Sorry about my phone there. So then go ahead and add those together. That'll give you 4x, and then bring down the minus 6. Again, you got to keep going because they're of the same degree now, right? This is, remember, you can stop once the degree of this is less than that. So again, what would you multiply x by to give you 4x? Well, you'd multiply by 4. So take 4 times each one of these, which will be 4x minus 4, and then just go ahead and subtract. So it'll give you minus 2. So the answer for this then would be x squared plus x plus 4 plus the remainder of minus 2 over x minus 1, right? And I guess if you want to write that as x squared plus x plus 4 minus 2 over x minus 1, you could do that, right? Because plus a negative is a negative. Or again, like I said, you could write it as x squared plus x plus 4 with remainder equal to negative 2. Now, and again, you might want to double check your work here just to be sure. Again, I won't bother checking this one, but you could check this by taking this times that plus the negative 2, and it should give you the x cubed plus 3x minus 6. Now there is another type of division that you can do, which is called synthetic division, which is a kind of a quicker version of long division. And this is I don't know if I'll ask any questions about this in the exam, but this might be useful when you go on and take college algebra, because in college algebra you might have problems where you have to do a lot of division, and so this is a little bit faster. But let's say, for example, you wanted to do something like this, where you're taking x squared plus 3x minus 2 and you're dividing it by x plus 1. Right, you'd kind of go through the procedure here, multiply by x, subtract, multiply by 2, subtract. And that doesn't take very long. But if you think about it, the subtraction signs aren't really necessary, right? And here, these two terms here are always going to cancel here and here. So you can kind of leave those out, right? Because you're basically taking, 3x minus 2x. So you could kind of do this without all this extra work here. In fact, you could kind of eliminate the x's if you kind of keep things lined up, right? If you keep the x's lined up under the x's and things like that. In fact, that's the main reason why you put the missing power of x in here, right? Is so you can keep the x squareds lined up with the x squareds. You don't have to put the 0x in, but it'll make things a lot easier. And one thing I should mention too is that at least this form of synthetic division, you can only do synthetic division if the thing you're dividing by is of the form of x to the first plus or minus some number. So if you're dividing by, like, say, x squared, there is a synthetic procedure for that, but it's a little bit different in the case where you have 1 degree. So you can really only do this where the degree of the polynomial is 1. So basically what you can do in this case is you can get rid of the x's and just write down the coefficients, write down 1, 3, negative 2, and then just do the operations without the x's in there. In fact, there's a more efficient way you can write this. You can sort of write it this way, and then this will turn out to be the remainder here on the end. So just to show you how this works, what you basically do is you just copy down the coefficients of the dividend. So let's say we want to take this and divide it by this. So what that means is write down 3, 2, negative 1. And if you do have missing powers, you have to put zeros in there like that for before. Change the sign on this from whatever it is to the opposite. So here you've got a negative 2, right there's a plus 2. And just put the 2 down there. You don't even need to put the x down. And then just start by bringing this row down. Right? So then you take this row down, and then what you do is you multiply the thing in this row times that, which gives you 6, and then just subtract. So, or just add them together, I'm sorry. So you'll take 2 plus 6, which is 8, and then do the same thing again, right? So take the 8 times the 2, which gives you 16, add those together, and that gives you 15. The last number here will be the remainder, and you can think of this as the constant term, and this is the coefficient in front of the x term. So in this particular case, when you divide, you'll basically get 3x plus 8 with remainder equal to 15. Right? So the answer will be 3x plus 8. That'll be the quotient, and then you'll get the remainder is equal to 15. And you can check that if you want, right? If you take 3x plus 8 times the thing we were dividing by, which was x minus 2, it will give you the dividend. So basically what you would do then in this case is, again, just set it up by putting the 1, 3, negative 2 down, and then in this case change the 1 to a negative 1, and then changing this to the negative 1 takes care of the subtraction that we were doing before, and then just start by bringing this down, right? So bring the 1 down, then take this number times that, which gives you negative 1, add those together gives you 2, Then again, take this number times that, which gives you -2. Just add them together, which gives you -4. So in this case, the answer will be x plus 2 with the remainder equal to -4. Right? Or you could write it as x plus 2 plus -4 over x plus 1. Here's another example. So in this case, again, what you do is you just write down the 1, 4, 8. And I actually like to put bars in here so I don't accidentally think of that as 14. And then some people will take the -3 and they'll write it up here in a box. You can put the division symbol in there if you want to. It doesn't really matter. And then again, just do what we did before. Bring down the 1. 1 times -3 is -3. Add these together gives you 1. 1 times -3 is -3. Add those together, you'll get 5. So you'll get x plus 1 with the remainder equal to 5. And like I said, I don't know if I'll have any problems where you have to do synthetic division on the exam. Maybe on the my math lab, but probably not on the written exams. But if you are going to go on and take college algebra, this might be something you might want to practice. So again, basically what you do is you bring down the 1, take the 1 times the -3 gives you -3. 4 and -3 is 1. 1 times -3 is -3. Gives you 5. Again, this number on the end is the remainder. And this will be the coefficient of the x term, coefficient of the constant term, and the remainder will be 5. And then again, you could certainly check that by taking the quotient times the thing you're dividing by plus the remainder, and it should equal x squared plus 4x plus 8. Maybe just to do a couple more examples here, let's do some more here. So let's say I want to divide this polynomial by that, right? So I'd change the sign here from a negative to a positive, and then just put the coefficients here, right? So I'll get 1, -7, 13, and 3. Again, if you want to put bars in there, you don't have to do that, but it might help you. Then bring down the 1. 1 times 2 is 2. Add those together gives you -5. -5 times 2 is -10. Add those together gives you 3. 3 times 2 is 6. Add those together gives you 9. Right? So in this case, this would be the remainder. So the remainder would be 9. This would be the constant term 3. This will be the number in front of the x, which will be 5. And then you'll get 1 times x squared. So you'll get x squared minus 5x plus 3 with remainder equal to 9. And again, you could check this by taking the x squared minus 5x plus 3 times the x minus 2, and then adding the remainder 9. It should give you the numerator there. So here's one where we have a missing 0. So again, I'll take the number on the bottom, change the sign. And then for the division part here, right, I got to put in a 1 for the x cubed. There is no x squared term, so I got to put a 0 in for that. Then -3, and then 10. Right, so in this case, again, I just start out by bringing down the 1. 1 times -1 is -1. Add those together gives you -1. -1 times -1 is a positive 1. Add those together will give you -2. -2 times -1 is a positive 2. Add those together to give you 12. So in this case, the answer is x squared minus x minus 2 with remainder equal to 12. And that would be your answer. Now for this one, you can't do it using synthetic division because you have to divide by something where you have x to the first. Now there is a way to actually do a version of synthetic division with x squared here, but we aren't going to go into that. So, but like I said, I'll probably just give you a problem on the exam, like this, where I ask you to divide, and you can either do regular long division or you can do synthetic division, whichever you would prefer. You should get the same answer either way. Okay, so that brings us to polynomial functions. So if you're dividing polynomial functions, this is very similar to what we did in previous sections. Again, you're just going to take a polynomial and divide it by another polynomial. So if a problem asks you to take f of x divided by g of x, just take the polynomial for f of x, right, they should give you that, and divide it by the polynomial for g of x. And in this case, because we are dividing by a monomial, we can just take each term and divide it separately, right, and that will give you 2x plus 3. Now, you can actually do the long division on this if you want to, right? You can put in 3x squared and do the 6x cubed plus 9x squared. I should maybe put in missing zeros here, but you don't have to do that. But you could say, what would you multiply 3x squared by to get 6x cubed, right? That would be 2x. Take that times that, which will give you 6x cubed. Subtract, you'll get 0. Then bring down the 9x squared. what would you multiply 3x squared by to get 9x? You'd multiply by 3, so take 3 times that, which will give you 9x squared, subtract, and you do get a remainder of 0. So you can get the right answer by doing long division, but remember, if the thing on the bottom is a monomial, it's probably faster to just do it this way and then just reduce, right? 3 goes into 6 twice, x cubed divided by x squared is x. Here, 3 divided by 9 is 3, and x squared divided by x squared is just 1. Now, there are a couple of theorems at the end of this section, and I doubt very much I would test you on this. We're kind of getting into material that's a little bit more college algebra level, but I did want to maybe talk about these a little bit. And you might see these on the written exam, or on the My Math exams, which you probably won't see these on the written exams. But the remainder theorem says, let f be a polynomial function. If f of x is divided by x plus or minus some number, then the remainder is the function evaluated at the opposite sign of whatever that number is. So let's say that you wanted to figure out what's the remainder when you take x squared plus 4x minus 5 and you divide it by x plus 2. Well, one of the ways you could do that is you could actually do the division and see what the remainder is. But maybe all you're interested in is the remainder and you're not so concerned about the quotient. What you could do is you could just take the thing you're dividing by, right? So this would be like x minus a negative 2. So in this case, c would be negative 2. And then just put in negative 2 into the function on top for the x, and that should give you the remainder. So I'll just take negative 2. Wherever I see an x in the numerator, I'll just replace that with negative 2, and that gives me negative 9. And that should be the remainder. Just to convince you of that fact, let's actually do the division in this case. So let's do synthetic division in here, right? So I'll take the negative 2, put that in the side there, and then the coefficients here are 1, 4, and sorry, the negative 5 got kind of cut off here. If you actually do the division, it should give you the same answer, right? So you'll get 1, negative 2, 2, negative 4, negative 9, and remember that number is the remainder, right? So that might not be that big of a deal for this one, but you can imagine if you had a much longer polynomial, like maybe something where you've got x to the 12th power in there, right? It'd probably be a lot faster to find the remainder this way than it would be to actually doing the division. So let's do another example. So what I can basically do in this case is if I want to just find the remainder, right, the remainder should be the function on top, the function I'm dividing into, or the dividend, in other words. Take this number, change its sign, and just stick it in for the x on top, right? So if I do that, I'll get 9 minus 12 plus 8. So that gives me 17 minus 12, or 5. And again, if you don't believe me, you could actually do the long division on this one. Let's do synthetic in this case, right? So you'll get 1, 4, 8. So bring down the 1, negative 3, 1, negative 3, and you do get 5 as a remainder, right? So it does give you the remainder. A couple things about the remainder theorem is, it allows you to find the remainder without dividing. And then another thing you can do is use the fact that with the division algorithm that we saw before, right? The fact that the quotient equals the dividend equals the quotient times the divisor plus the remainder. If it turns out that the remainder is 0, then that means that the dividend will actually, you can break that up into the quotient times the divisor, right? And then you would add the remainder, but if the remainder is 0, there's nothing to add on there, right? So that means that, if you have a number like 6, you could factor that as 2 times 3. And we'll maybe use this in the next section to factor, because we're also going to factor polynomials. Like if you have something like, say, x squared times x minus 6, we'll see that you can factor that into x minus 3 times x plus 2, where there's no remainder on there. Okay, the last result we want to look at is called the factor theorem. This is kind of related to the remainder theorem, but it says that if x minus c is a factor of x, in other words, what that means is you can write, so let's say you're dividing f of x by x minus c. To say that x minus c is a factor says that you can write f of x as x minus c times some polynomial. right, plus whatever the remainder is. But if the remainder is 0, right, it means it can factor. So basically, if you can replace the x on top with the c on the bottom, and you get 0, which would imply by the remainder theorem that last thing is 0 here then you can actually factor the polynomial, right? So let's say we want to figure out is 3x squared plus x minus 2, does it have a factor of x plus 2? In other words, can you write 3x squared plus x minus 2 as x plus 2 times some other polynomial, right? It doesn't really matter what this is, but this will wind up being the quotient, right? Because this is the dividend and the divisor. This would wind up being the quotient, and then you'd have the remainder. But we're not actually being concerned about what the quotient is. All we want to know is, can we factor this or break this down into two separate things? So in this case, what you could do is you could just take the 2 here and then just change the sign and stick it into the polynomial on top, right? And you get 8, so the remainder is not 0, so that would mean that 3x squared plus x minus 2 is equal to x plus 2 times some quotient, but then the remainder would be 8. So this cannot be factored into that times that because you've got the remainder, so this is not a factor of that. Let's say, for example, we wanted to show that x minus 2 is a factor of this, right? So what you could do is just figure out p of 2. So that'll be 8 plus 2 times 4, which would be another 8, minus 2 times 3, 3 times 2, which would be 6, minus 10. So you do get p of 2 is equal to 0, and that would mean then that you can write x cubed plus 2x squared minus 3x minus 10 as x minus 2 times some quotient polynomial. Right now, to actually find the quotient, you'd have to do the long division. But maybe you want to figure out, can you even factor this polynomial to begin with before you go ahead and do the long division. You can also do this sort of in reverse. Let's say you've got a polynomial of degree 3, and it has these zeros. That means that the polynomial that you're looking for should factor into x minus this number times x minus this number times x minus negative 1. Right? And so that'd be x minus 1 times x minus 2 times x plus 3, or plus 1, sorry. And then you could FOIL that all out if you wanted to. It would give you a degree 3 polynomial because you've got x times x times x. So this is kind of leading us into what we're going to do in the next chapter, or one of the later chapters, which is taking a polynomial and breaking it down and factoring it. Let's maybe look at another couple of examples. Let's determine is x minus c a factor of this polynomial, right? So in other words, if I take f of 3, do I get 0, right? Is the remainder 0? So it'd be 3 squared plus 5 times 3 plus 6. Well, there's no way that can be 0, so the answer to this would be no, right? X minus 3 is not a factor of that polynomial. Right? If you take negative 2 and put it in here, right, as p of negative 2, is that 0? So in this case, you'd have 5 times negative 2 cubed plus 8 times negative 2 squared minus 7 times negative 2 minus 6. Is that equal to 0? Right? So in this case, you'll get, what, 5 times negative 8, so that would be negative 40 plus 32, right, because negative 2 squared is 4, plus 14 minus 6, right? So is that going to be 0? So this will be, what, negative 8 if I combine these two together. This will give me a positive 8, so I do get a 0 there. So that would mean that, yes, x minus a negative 2, or in other words, x plus 2 is a factor of that polynomial. Okay, well, hopefully that clarifies that section. So the main thing we're going to look at is, like I said, I don't think I'll have any problems where I'll require you to use synthetic division, but if you are going to go on and take college algebra, that might give you a little bit of a leg up. So anyway, so if anybody has any questions or anything about that, let me know. But the main thing you should know how to do is, make sure you know how to do long division, because remember, you can't use synthetic division for every problem. So if you're going to either learn, one of these two things, either just learn long division. But if you're going to learn both things, right, it wouldn't hurt to do both, right? But if you're not going to do synthetic division, right, make sure that you know how to do long division. All right, well, hopefully that makes sense. Like I said, if you guys have questions, just let me know.